I had another.
Hi students, welcome to the next online lesson of problem solving methods. And today we will talk about the presentations that you prepared for individual work. I gave you some topics in mathematics and it will affect your final result. So thank you so much for your attendance, for your patience, despite the obstacle of the online lessons, the online platform, the barriers of online platform. And let's start our presentations. So who starts? Let me share the screen and okay. First is exponential functions.
Yes.
This is the topic of Aynur and Aygül, yes?
Yes.
Okay, let's start. Please.
Welcome our explanation. I am Aygül and my partner name is Aynur.
Welcome. Today I will explain to you exponential and logarithmic function. Firstly, we want to begin with exponential function. A function of the form fx is equal to b to the x, where b is fixed natural number, b is greater than 0, b is not equal to 1, is called a base b exponential function. And this is this graph.
Okay.
This is properties of exponential function. The domain of and range of as you see this one, and 0 1 is the on the graph of f, and y is equal to 0 is a horizontal asymptote to the graph of f. F is 1 to 1, continuous and smooth. And this number is called the natural base. The function fx is equal to a to the x is called the natural exponential function.
Okay.
If b is greater than 1, this is graph, and as you see, f is always increasing. And if b is greater than 0 and smaller than 1, this is graph, and as you see, f is always decreasing.
I want to speak the logarithm function. The inverse of the exponential function fx is equal to b to the x is called the base b logarithm function and is denoted by the inverse fx is equal to logarithm base bx. The common logarithm of a real number x is logarithm base 10 of x and is usually written as so. The natural logarithm function of a real number x is logarithm base e of x and is usually written as ln x. We have special notation for the common base b is equal to 10 and the natural base b is equal to e.
Okay, great. Properties.
And in this picture, properties of logarithm and the domain and the range of logarithm. The domain of f is minus infinity to positive infinity, and the range of f is 0 to positive infinity. 0 is on the graph of f and x is equal to 0 is a vertical asymptote of the graph of f. As you know, logarithm and exponential function are one-to-one, continuous and smooth.
Can I ask a question?
Yes.
Yes, certainly.
In which condition we can say that this function has inverse? Logarithmic and exponential functions
Yes.
are inverse functions of each other.
Yes.
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 Why? In which condition are they satisfied? They are one-to-one. If a function is one-to-one, for every input there is one output, then the function is 1 to 1 and it has inverse function. And you say that both logarithmic and exponential functions are inverse. So they are 1 to 1, so they are inverse of each other. Please continue.
Then in this picture, the graph of logarithm function, if b is greater than 1 in this picture and f is always increasing. If b is greater than 0 and b is smaller than 1, second graph, and f is always decreasing.
Yes, great. And let's continue. Inverse properties of exponential function.
Yes. I want to speak about inverse and one-to-one properties of the exponential and logarithmic functions. Firstly, inverse properties. Let b is greater than 0 and b is not equal to 1. B to the a is equal to c if and only if logarithm base b of c is equal to a. Logarithm base b of b to the x is equal to x for all x, and b to the logarithm base b of x is equal to x for all x is greater than 0.
Great.
Second, one-to-one properties about them. Let fx is equal to b to the x and gx is equal to logarithm base b of x, where b is greater than 0 and b is not equal to 1, then f and g are 1 to 1. B to the u is equal to b to the double if and only if u and u is equal to w for all real numbers u and w. Logarithm base b of u is equal to logarithm base b of w if and only if u is equal to w for all real numbers e and w is both of them are greater than 0.
Yes.
And there are some examples about this topic.
Great. You don't need to explain the examples.
Yes.
You solve them already.
Yes.
So algebraic properties of logarithmic functions.
Yes. Let gx is equal to logarithm base b of x, be a logarithmic function. B is greater than 0 and b isn't equal to 1, and let u is greater than 0 and w is greater than 0 be real numbers. And you see three rule: product rule, power rule, and quotient rule about the logarithmic function. And
Each function.
Product rule, quotient rule, power rule, change of base formals.
Yes, about the logarithm and exponential function.
Great.
And there are some examples.
And this is some examples of logarithm function.
Okay, girls, you don't need to explain the examples. Thank you for your effort. Thank you for your hard work. Great. You gave all the information in detail and you briefly explained your presentation. Thank you. Great.
Thank you for attention.
Thank you, teacher.
And next, who is next? Let me. Who is this? Aysel and Rexana.
Yes.
What is your topic name?
Analyzing
graphs of functions. Great. Let's start. Aysel. Are you ready?
Can I start?
Of course, Rexana, please.
Hello, everyone. I am Roxana. I want to talk about analysis graph of function. First of all, what is a function? A function f from a set A to a set B is a relation that assigns to its element x in the set A exactly one element y in the set B. The set A is a domain or set of inputs of the function f. The set B contains the range or set of outputs.
Mhm.
Then, four ways to represent and function: one verbally, two numerically, three graphically, and four algebraically. We talk about graphically. Uh, the
The graph of a
the
function.
graph of
Mhm.
yes, a graph of a function. F is a collection of ordered pairs x and fx such that x in the domain of f. Remember that x equals the direct distance from the y-axis. Y equal fx equals the direct distance for the x-axis.
Mhm.
Zeros
The
of a
graph of
function.
function includes
Mm.
Uh-huh.
zero of function, um, increasing and decrease function, also even and odd function. We talk about zeros of function.
Uh-huh. I said, please continue.
Uh, for example, to find the zeros of a function, set the function equal to 0 and solve for the independent variable. Even and odd function. In terminology of functions, a function is said to be even if its graph is symmetric with respect to the axis, and to be odd if its graph is symmetric with respect to the origin. Tests for even and odd functions. A function's y equal to f x is even if for each x in the domain of f minus x equal to fx. A function y equal to fx is odd if for each x in the domain of f minus x equal to minus fx.
Great.
This is
And
the
this is the
example.
example of the function gx is
This is example.
uh-huh.
Yes. The
Yes,
graphs and symmetry of these two functions are shown the picture in the picture.
Uh-huh. This is the graph of
on the graph.
x is equal to x cubed minus x, the first one. This is odd function, and the second one is even function, x squared
Even
plus
function.
1. Great. Increasing and decreasing functions.
Yes. A function f is increasing on the interval if for any x1 and x2 in the intervals x1 less than x2 implies x1 less than x2. A function f is decreased on the interval if for any x1 and x2 in the interval x1 less than x2 implies if x1 greater than if x2. The picture one picture is uh, increase. Second picture is decrease on the graph. The next example is increase and decrease.
The graph
Yes,
is also increasing and decreasing in some intervals, yes?
yes, yes.
Uh-huh.
Uh,
Increasing
teacher
while
also
is minus infinity to minus 2, and decreasing while the interval is minus 2 to 0. So,
yes.
great, thank you.
Teacher
Yes, please.
also I want about something about increase and decrease.
Uh-huh.
Uh, we are given some example and we construct a graph of function increase and decrease.
Uh-huh.
Then uh, um, the graph is going to look something like it's going down as you go from left to right is a negation slope and decrease function. Then like it's racing as you go from left to right is positive slope or increase slope. The increase function is positive slopes as a meaning, as a name. Negative slope is decrease slope. Also, I remember that my teacher said on the graph, we move our left hand on the graph from left to right,
We move our
where yes,
from left
yes,
to right. Yes. And
yes, where our hand goes up, then this part is increasing
uh-huh.
or positive slope.
Uh-huh. Yes. Your teacher is she's right. And thank you, girl, Roxana,
Thank you.
Thank you.
for your such a great presentation, such a detailed presentation. I think there is no unclear part. Everything is clear. You gave tons of examples, and that's all. Thank you.
Thank you.
Next one is Behmen. Yes. Let me open the presentation. Graph of equations. Please, Behmen.
Welcome to everybody. I am Rahman and my presentation is about graph of equation. Firstly, we must know that what is equation. In algebra, an equation can be defined as a mathematical statement consisting of an equal symbol between two algebraics that have the same value. The most basic and common algebraic equation in math consists of one or more variables. For instance, 3 times x plus 5 equal to 14 is an equation in which 3 times x plus 5 and 14 are two expressions separated by an equal sign. In an algebraic equation, the left-hand side is equal to the right-hand side. Here, for example, 5 times x plus 9 is the expression on the left hand side, which is equal to expression 24 on the right hand side.
Great.
And those are the intercept of a graph. It is often easy to determine the solution points that have 0 as either the x-coordinate or the y-coordinate. Those points are called intercepts because they are the point at which the graph intersects the x or y axis. Some text denotes the x-intercept as the x-coordinate of the point rather than the point itself. Unless it is necessary to make a distinction, we will use the
Mm-hmm. Something went wrong with the set of Behman.
Maybe internet connection.
Yes. But I looked through the presentation of Behman. He talked about graph of equations and he gave examples. Y-intercept, here is x-intercept. Yes, great. And graph of quadratic equations. Yes, as you see, this is the parabola. Is a graph of quadratic equations. And that opens down is said to be concave down. Right. The point for 0 is known as the vertex. Yes, here is the example of quadratic equation. And graph of polynomial equation is also shown here. and any equation higher in degree than a quadratic is given the name polynomial. Yes, as demonstrated below, the graph of a polynomial winds up and down. And two important characteristics of polynomials: turning points, increasing, decreasing, perfectly shown.
Yes.
There is some problem with Bahman's internet connection, but we saw his presentation is really very detailed, very clearly explained, and he is also one of my diligent students, but there are lots of barriers of online platform as this internet. So Bahman got the highest point also. Thank you, Bahman. I hope you will see our video, and you are so dedicated. Thank you. And next, who is next?
Şefek Dürdane.
Aynur,
Şefek Dürdane.
Dürdane and Shafak, yes? Okay.
Hi everyone, my name is Shafak and my partner's name is Durdana. First of all, thanks for your attention and welcome to our presentation. Today we will try to explain our topic clearly, and our topic will be about polynomial function of higher degree. So let us start. First of all, I want to talk about what we should learn from this slide. Use transformation to sketch graph of polynomial function. Second, use the leading coefficient test to determine the end behavior of graphs of polynomial function. Find and use zeros of polynomial function as sketching aids. Use the intermediate value theorem to help locate zeros of polynomial function. Next slide.
Graphs of polynomial function. At this point, you should be able to sketch accurate graphs of polynomial function of degrees 0, 1, and 2. Function graphs: fx equal a, horizontal line; fx equal ax plus b, line of slope a; fx plus ax square plus bx plus c, parabola. The graphs of polynomial function of degree greater than 2 are more difficult to sketch by hand. However, in this section, you will learn how to recognize some of the basic features of the graphs of polynomial function. Next slide.
Okay.
Graphs of polynomial function. Using these features along with point plotting, inserts, and symmetry, you should be able to make reasonably accurate sketch by hand. The graph of polynomial function is continuous. Essentially, this means that the graph of polynomial function has no breaks, holes, or graphs. As shown, A. Polynomial function have continuous graphs. B. Function with graphs that are not continuous are not polynomial functions. Next slide.
The graphs of all polynomial functions are smooth and continuous. A polynomial function of degree n has the form fx equal a base n of x to the n plus a base n minus 1 x to the n minus 1 plus a base 2 of the x square plus a base 1 x plus a base 0, where n is positive integer and a base n not equal 0. The polynomial functions that have the simplest graphs are monomial of the form fx x base n, where n is an integer greater than 0. The greater the value of n, the flatter the graph near the origin. Next slide.
When n is even, the graph is similar to the graph of fx equal x squared and touches the x-axis at the x-intercept. When n is odd, the graph is similar to the graph of fx and cubed x, fx equal to cubed x, and crosses the x-axis at the x-intercept. Polynomial function of the form fx equal to x power n are often referred to as power functions. Next slide.
Zeros of polynomial function. If f is a polynomial function and a is a real number, then the following statements are equivalent. First, x equal a is a zero of the function f. Second, x equal a is a solution of the polynomial equation fx equal 0. Third, x minus a is a factor of the polynomial fx. Fourth, a and 0 is an x-intercept of the graphs of f. Related zeros for a polynomial function, a factor of x minus a base k greater than yield a repeated zero x equal a of multiple k. First, if k is odd, then the graph crosses the x-axis at x equal a. Second, if k is even, then the graph touches the x-axis but does not cross the x-axis at x equal a. Next slide.
The intermediate value theorem. The intermediate value theorem concerns the extents of real zeros of polynomial functions. The theorem states that if a and fa and b and fb are 2 points on the graph of polynomial functions such that fa doesn't equal fb, then for any number d between fa and fb, there must be a number c between a and b such that fc equal to d. Let a and b be real numbers such that a greater than b if f is a polynomial function such that if a doesn't equal to fb, then in the interval a and b, f takes on every value between fa and fb. Next slide.
Example, find three intervals of length, one in which the polynomial fx and 11 x cubed minus 32x squared plus 3x plus 5 is created to have a zero. Solution from the table you can see that f minus 1 and f 0 differ in sign. If x is minus 2, y is minus 225 x. If x is minus 1, y is minus 42. And then, next slide.
And
So you can
yes, please.
So you can conclude from the intermediate value theorem that the function has a zero between minus 1 and 0. Similarly, f0 and f1 differ in sign, so the function has a zero between 0 and 1. Likewise, f2 and f3 differ in sign, so the function has a zero between 2 and 0. So you can conclude that the function has zeros in the intervals minus 1 and 0, 0 and 1, and 2 and 3. Thank you.
Great, girls. Thank you, Shafak and Dürdane, for your hard work. You are my dedicated students. Thank you so much. There is no unclear part in your presentation. Also, you gave a brief information about the limit of our time. So great, girls. You got the highest degree. All of you got the highest degree. Thank you for your effort. Thank you for your tireless works. And so this is the end of our lesson. Yes.
Fidan Sema Galbi.
Fidan Sema, really? Okay. Let me Okay, let me open the email again. And Fatima and Tarana, let's start. Your
Hi.
topic is trigonometric equations, yes?
Yes.
Yes. Okay, start please.
Hi guys, I perform with Sarana and my partner Fatima. Our topic is trigonometric equations. We want to speak you about this topic. Let's begin. Trigonometric equations. Trigonometric equations are equations including trigonometric functions. Definition: an equation containing an unknown under the trigonometric function sign is called trigonometry.
Yes, there are types of trigonometric equation. For example, look at the picture. This is simplest trigonometric equation. Next page.
Okay.
And there are also case of simplest trigonometric equation. The picture on the left is sine special case equation, and the picture on the right is cosine special case equation. And this picture is tangent and cotangent special case equations.
Great. And here is methods for solving trigonometric equations. Yes, which methods are they?
Yes. Solving trigonometric equation consists of two stages. First, transforming of the equation to receive its simplest shape, and second, solving of the receive its simplest trigonometric equation. There are 5 methods for solving trigonometric equation. First of all, algebraic method.
Great, yes.
Next. Next page.
This is the algebraic method, yes? You gave example and solution, the strategy for algebraic method.
Yes.
And the second is factoring. Great. Reducing a homogeneous equation. Please continue.
Yes, second.
Teacher. Yes, factoring. Yes, Fatima.
Reducing to a homogeneous equation. To solve the homogeneous equation, it is necessary: A. A. To transfer all terms to the left-hand side. B. To take all common factors out of brackets. C. To equate all factors and brackets to 0. D. The brackets equated to 0 gives the homogeneous equation of the smaller degree, which should be divided by cosinus or sinus of the higher power. E. To solve the received algebraic equation in tangent.
And you gave a brief example and the solution method. Great. I think it's enough. And for transforming a product to a sum. Great. This is enough. We don't have enough time. And thank you for your effort and your hard work, Tarana and Fatima.
Thanks, teacher.
Great. Let's continue. Next. Who is next? Whose is this topic? Polynomial functions of, continue please, higher degree. Whose is this? I guess it is
Bu sabahınki diye.
Dürdane and Şafak. They are not ready today. Okay, we'll continue it tomorrow. And this is distance, speed, time. Whose is this topic?
The teacher, Aytaç and Zahra.
Zahra and Aytaç. Okay, Zahra and Aytaç. Let's start.
Hello, everyone. First of all, thanks to each of you for watching our presentation. Our topic is solving problems about distance, speed, and time. Firstly, we will talk about definition. What is this? Distance is the length between two parts measures in miles, kilometers, meters, etc. Speed is the distance traveled per unit of time, and time is duration of traveling the given distance at a certain period measures in second, minute, hour, day, week, year, and next page.
In this page has the formulas of speed, time, distance. Distance is equal to speed times time, which implies speed is equal to time over distance. Time is equal to speed over distance.
Page.
Great.
Now, let us give some example of the distance, time, and speed. Problem number 1. As you see, this question gives us speed and time, and require us find distance. So speed is 50 miles per hour, meaning that car moved 1 hour is 50 miles. So a person can cover 125 miles of distance in 2.5 hours.
In this problem, we find speed. We first convert kilometer to meters and hour to seconds. Then we solve the problem with the formula of speed. Speed is equal to time over distance.
Great. Yes.
Next page.
Problem 2, yes?
Yes.
Continue, please.
Problem number 3. These questions require us to find times. As we know, times is equal distance over speed by formula. So the person will take 4 hours to cover 160 miles distance at the rate of 40 miles per hour.
And there are plenty of solving method of problems, yes. Let's continue question on boats.
Yes, this page shows how to solve problems with a boat. Speed of the boat upstream is equal to speed of the boat in still water minus speed of the stream. Then speed of the boat downstream along with the current is equal to speed of the boat in still water plus speed of the stream.
Yes, and problem number 6 is similar, yes?
Yes.
Yes.
About boat question.
Do you want to explain?
No, I think no need.
Okay, it's enough. Okay, thank you.
Thank you.
I
you.
liked it. You gave a brief information. Also, you gave detailed information about this topic. You solved plenty of problems. And I think it's obvious to each of us. There is no unclear parts. Great, thank you, Zahra and Aytaj. Let's continue. Who is next? Okay. Gülbeniz and Hasret. Are you here?
Yes. Hasret, tell you.
Please. Hi everyone. My partner name Gülbeniz. We topic name methods for solving exponential functions. In addition, an example of an exponential function is the growth of bacteria. Some bacteria double every hour. If you start with one bacterium and it doubles every hour, you will have bacteria after hours. This can be written as before you start, after 1 hour, in 2 hours, and 3 hours, and so on. Look at this picture. Look at this picture.
This is graph.
Yes.
And exponential growth.
Exponential growth. As you can see above, this exponential function has a graph that gets very close to the x as the graph extends to the left, but never really touch the x.
Yes, it extends to the left, but never touch to the x-axis. Yes.
Yes, yes, teacher. Please.
Next page.
Yes.
The graph is increasing because b is greater than 1. B is the base, or 3 is the base.
You explain the graph, yes?
Yes.
The graph is increasing, yes. What is base?
Increasing. Base b.
B.
X is exponent.
Yes. So, what else? The example about this problem, yes? You gave it the example and the answer. T to start the table with 2 columns. Okay. This is x variable and fx. And you give the input and output. Great. And another example. Please explain this example. Fx is equal to 3 to the x. Who wants to explain this? Gülbeniz?
Teacher,
the graph fx is equal to 3 to the x, as in your screen.
Graph f plus x is equal to 3 to the x power.
Equal in the horizontal sector is equal.
It starts with a table of values, like the one in the example above, yes? You gave input -2 and output also 1/9, -1, 1/3, and etc. Yes.
Yes.
Great. And this is, we plot the points to the graph. Yes. Great.
Thanks.
Thank you for your diligentness. And let's continue. Who else? Continue, please. Nermin. Your topic is linear equation into
Yes. Hi, everyone. My name is Nermin Guliyeva, and I want to introduce my partner names. Her name is Matanet, and today, first of all, thank you very much for your attention, and we will introduce our individual work. And our individual work will be about linear equation in 2 variables and method of solving problems, slope-intercept, point-slope form, the slope of a line passing through 2 lines. Yes. No, so let's start. Linear system with two variables. What is linear system with two variables? A linear system of two equation with two variables is any system that can be written in the form a times x plus b times y is equal to b, and c times x plus d times y is equal to q, where any of constant can be zero, with the exception that each equation must have at least one variable in it. And then, Matahat, continue, please.
Okay, here is an example of a system with number. Example exercise it is. And its graphics we have there. And we will be looking at two methods or for solving system in this section. The first method is called the method of substitution. In this method, we'll be solve one of the equation for one of the variables and substitute this into the other equation. This will one equation with one variable that we can solve. Once this solved, we substitution this value back into one of the equation to find the value of the remaining variable. And we have exercise example there. And this second method is called what?
Yes. The method of elimination
is yes, method of elimination. In this method, we multiply one or both of the equation by appropriate numbers, so that one of the variables will have the same coefficient, and opposite things.
Here you gave an example about this two variable linear system and the method of elimination. What did you do? 5 times x plus 4 times y is equal to 1. And 3 times x minus 6 times y is equal to 2. Here is work for this step. Yes, great. So, who wants to continue?
Yes, me. There is a third method that we will be looking at the solve system of two equations, but it's a little more complicated and it's probably more useful for a system with at least 3 equations. So we will be looking at in the later section. Our example, x minus y is equal to 6, and minus 2 times x plus 2 times y is equal to 1. So we solve this equation above example, and so this is clearly we get minus 12 is equal to 1, and it is not clear, and it's not clear for us. So this is clear,
minus
true,
12
and this doesn't appear to be a mistake anywhere in our work. So what is the problem? To let us
continue, yes, please.
Minus 12 is we do our work clear, but we get minus 12 is equal to 1. It's not true, but so let's check. We look at graph. We see that our function graphs is parallel. So it appears that these two lines are parallel, and we know that two parallel lines with different y-intercept will never cross.
Yes.
So yes. So what is next page? What is slope-intercept form of two variables linear equation? Slope-intercept is a specific form of linear equation. It has the following general structure. Y is equal to m times x plus b. Here m and b can be any two real numbers. For example, these are linear equation in slope-intercept form. Y is equal to 2 times plus 1. 2 times x plus 1 and here and so on other hand, these linear equations are not in slope-intercept form. For example, 2 times x plus 3 times y is equal to 4. Above example, we know that 2 is our slope-intercept form, and but above example, we don't have slope-intercept form. Yes.
So
And
continue, please.
And yes, the coefficient in slope-intercept form, besides being neat and simplified, slope-intercept form's advantage is that gives two main features of lines in represents. The slope is m, the y-coordinate of the y-intercept is b. In other words, the lines y-intercept is at 0 and b. For example, the line y is equal to 2 times x plus 1 has a slope of 2, and y-intercept at 0 and 1, as we see at our table.
Great. I think that's enough.
The fact this form gives the slope and y-intercept in this reason why it's called slope-intercept in the first place.
Okay,
yes.
I think this is enough. This is enough.
Okay.
Thank you.
Thank you very much for your attention.
Thank you for your attendance. Thank you for your explanation. It was really helpful to all of us.
Teacher.
There is no unclear parts. You explained it very detailed, and great job. Keep going. Thank you, girls. Let's continue.
Teacher.
Thank you.
Let's continue. Asiman. Asiman and who? Great, Asiman. Let's start. Hi.
I am Asma Sharifli. I study Baku University. Then I can.
Asiman and Ayten.
Yes. I am Ayten Mahmudova. I study at Baku Engineering University as mathematics and informatics teacher.
Or today our topic is multivariable linear system. Then let's
start, please.
From back substation. The method of eliminations can be applied to a system of elimination of linear equation in more than two variables. In fact, this method is the adapts vector used for solving linear system with domains of variables.
Next.
Is açıldı.
No problem. Continue, please.
Gaussian elimination. Two systems of equation and equation, if they have the same solution set, the solved system, this is not a row equivalent form.
Next page.
First, convert it to an equivalent system that is in a row echelon. Operation that produce equivalent system. Each of the following row operation on a system of linear equation produce an equivalent system of linear equation. 1. Interchange two equation. Second, multiply one of the equations by an inzora constant. Third, add a multiply of one of the equations to another equation to replace the latter equation.
Example second, creation mentions to solve a system solving method. And the third example, solutions method using equations eliminations to solve a
Great. And here you gave
of linear equation.
Here you gave an example about Gaussian eliminations strategy. Yes, using this strategy. Great. What did you do?
Look at the example. X minus 2 times y.
Which one you need?
X minus 2 times y plus 3 times z equal to 9. Minus x plus 3 times y equal to minus 4. And look at the solving method. And another solving method is an inconsistent systems. Look at example 4. Solve the systems of linear equation 1, 2, and 3.
You add minus 3. Firstly, you add minus 2 times to the first equation to the second equation. Produce the new second equation. Yes, adding minus 1, then adding minus 1 times the second equation. Yes, great. Continue, please.
As with a system of linear equation into variables, the number of solutions a system of linear equations in more than 2 variables must fall into one of 3 categories. The number of solutions of linear system. For a system of linear equation, exactly one of the following is true. First case, there is exactly one solution. Second, there are infinitely many solutions. Third, there is no solutions.
And here is the example.
Yes. Another example, a system with infinitely many solutions solving method. Equations first, second, third.
In the last equation, solve for y in terms of the obtained y equal to z. Back substituting for in the previous equation produce x equal to 2 times z minus 1. Finally, letting z equal to a. Where a is a real number, you can see that the solution to the given system are of the form x equal to 2 times z minus 1, y equal to a, and z equal to a. And so every order triple of the form 2 times a minus 1, a is a real number, is a solution of the system. And another, yes.
So for each system of linear equation, you have looked has been shared with means that the number of equation is equal to the number of variables. In non-Shager systems, the number of equations different from the number of variables. A system of linear equation cannot have unquick solutions unless there are at least as many equations as here are variable in the system. And another example, a system with fewer equations than variables.
And look at solve the system of linear equation. Adding 3 minus 2 times the first equation to the second equation produced a new second equation. And then multiplying the second equation by 1 divided 3 produced a new second equation.
Yes.
Solve for y in terms of z to obtain y equal to z minus 1.
And partial fraction, data analysis, curve fitting. Yes, you gave lots of information about this topic, and all these informations are very detailed. Thank you for your dedicatedness. You are very tireless students, really diligent, diligent students. Thank you for your attendance. Thank you for your such a great presentation. I think we understand all of you, what you said. There is no unclear parts. And who is next? Who is next, please?
Esmer.
Röya?
Oh, Esmer.
Esmer and who? Esmer, okay, your presentation is here. Let's continue, Esmer. Esmer and Hasanova Nermin.
Hello everyone. Our topics is solving polynomial and rational inequalities. Firstly, I want to give information about polynomial inequalities. What's polynomial inequality? A polynomial inequality is any inequality that can be put in one of the forms f less than 0, f greater than 0, f less than or equal to 0, or f greater than or equal to 0, where f is a polynomial function. Procedure of solving polynomial inequalities. First, express the inequality the form f less than or greater than 0, where f is a polynomial function. Second, solve the equation f equal to 0. The real solutions are the boundary points. Source, locate the boundary points on a number line, thereby dividing the number line into intervals. First, choose one representative number called a test value within each interval and evaluate f at that number. A. If the value of f is positive, then if greater than 0 for all number x in the interval. E. If the value of f is negative, then f is less than 0 for all numbers x in the interval. Pass. Write the solution set, selecting the interval or intervals that satisfy the given inequality. There are some examples in there.
You don't need to explain the examples. Next. Solving polynomial inequalities.
Look at this.
Okay.
We give some information about geometrically solution. Please, Nermin, continue.
What is rational inequalities? Definition: a rational inequalities is an equality which contains a rational expression. The trick to deal with rational inequalities is to always work with 0 on one side of the inequality. Rewrite the problem if necessary to obtain a 0 on one side. Then the x values that make numerator 0 and the x values that make the denominator 0 will determine the number line test values. Solving rational inequality. Find the number line test interval and test each interval. First, if necessary, rewrite the inequality so a 0 appears on one side with a single fraction on other side. Second, find the x value that makes the numerator equal to 0. Third, find the x value that makes the denominator equal to 0. the values from step 2 and 3. Test interval. First, on a number line, mark each of the values from steps 2 and 3. Use only 3 values to create intervals on the number line. Fifth, select the test point in each interval and check to see if that test point satisfies the original inequality. Sixth, mark the number to line reflects the value and intervals that satisfy the inequality. Seventh, use interval notation to write the final answer. There are some quotes in there.
Okay, you don't need to explain all the examples, but as I see, you gave a detailed information about the examples and the solution methods of these examples. And also your work is very detailed, and you gave a brief information as we have not a time because of the time limit. And great work. Thank you for your hard work again. I appreciate your presentation, your explanation. Thank you, girls. And now this is the this is the final presentation for today. Yes?
Oh, teacher.
Yes.
I missed them. I don't.
Ben ve Röya kaldı.
Şefek, Dürdane, at last, me and Nermin.
And Bibi Hanım and Çiçek.
Çiçek and Bibi Hanım.
Yeah.
Yes, okay, we will continue it. Okay, girls, let's continue. Who is next? Jafarova Röya and Agayeva Bahar. Please start.
Thank you, teacher. Thank you for your attention. My name is Röya and my partner name is Bahar. Our presentation topic is about solving system of inequalities. Let's start, please.
Okay, let's start.
Okay. Solving system of inequalities. I want to say first the definition. Definition, system of inequalities. A system of inequalities is a set of two or more inequalities in one or more variables, and system of inequalities are used when a problem requires a range of solutions and there is more than one constraint of such solution, and we have to do them with firstly graphs, second a system with no solution, and third an unbounded solution set.
Here is examples, yes?
Yes, or graphs.
Great. You solve inequality system by
graphs. Yes. First of all, graphing methods. Let's begin. Solve the system of inequalities by graphing. Y less than or equal x minus 2. Other inequalities. Y
greater
than minus 3 times x plus 5. First graph the inequality minus y less than or equal minus 2
x minus
x minus 2. The related equation is
y equal to x minus 2. Since the inequality is less than or equal, not a strict one, the border line is solid, graph the straight line. Second, consider a point that is not on the line, say 0, 0, and substitute in equality. As you see, this is false. So the solution does not contain the point 0, 0. Shade the lower half of the line. Next page. Then similarly draw a dashed line for the related equation of the second inequalities, which has a strict inequality. Also the point 0, 0 does not satisfy the inequality. So shade the half that does not contain the point 0, 0. That's why the solution of the system of inequalities is the intersection region of the solution of the two inequalities. Next page.
Okay, quadratic systems
Yes,
with graph. Yes.
Yes, quadratic systems with graphs. There are some examples about quadratic system with graphing methods.
Great. Okay. And the system with no solution, yes?
Yes. No solution. A system with no solution. Example 1, a graph of non-linear inequalities that has no solution and has no overlapping sections. Here is the graph of the system. X squared plus 2 times x minus 1 less than y, and minus x squared plus 3 times x plus.
I think, sorry, this is x squared plus 2 times x, yes?
Yes. 2 times.
Okay.
Yes.
X squared plus 2 times x. Okay.
I'm sorry. And minus 3 2 greater than y. Notice that the graphs don't overlap at any point. It means there is no set of points that satisfies both equations, so we say there is no solution. And
as is clearly seen that in this explanation, in this graph, these two graphs don't.
There is no the same
Don't
point.
overlap.
Yes.
No, don't overlap. Yes.
In which conditions there
please show
no solution?
Yes. Unbounded the solution set.
Unbounded solution.
You mentioned that a system has no solution if two equations are parallel, yes? If two equations are parallel, then the system has no solution.
What I say?
And next, an unbounded solution set.
Yes, last solution, unbounded solution set. In unbounded solution of a linear programming problem is a situation where object V function is infinite. A linear programming problem is said to have unbounded solution if its solution can be made infinitely large without violating any of its constraints the problem. Since there is no applied problem which has an infinite return, hence unbounded solution always represent a problem that has been incorrectly formulated. Example 1, if we consider maximize x plus y subject to x minus y greater than or equal 1, x plus y greater than equal 2. So x, y greater than or equal 0. The feasible region is as follows. In the case, you can see we can move as much as we want the object function in the growing sense of x and y coordinates without leaving the feasible region. Therefore, objective function can grow into feasible region. So we are in an unbounded solution case for this problem. Next page, example 2. Example also unbounded about unbounded sets. You can also obtain solutions that are open or unbounded. That is, you will have some exercise which have solutions that go forever in some direction. Here's an example. Solve the following systems. 2 times x minus y greater than minus 3, 4 times x plus y less than 5. As usual, I first want to solve these inequalities for y. I get the rearranged system. This inequalities, graphing first inequality I get. Next page, graphing the second inequality. Yes, and finally, the solution is lower region where the two individual solutions overlap. The kind of solution displayed in the above example is called unbounded because it continues forever in at least one direction, in the case forever downward.
Okay.
Yes.
Your presentation is also very successfully made. Really, you gave thank you. You gave a detailed information. Your solution of the lower region where the two individual solutions overlap. Really, this graph is great. Thank you. Thank you for your, thank you for your industrial student. And let's continue. Who is next?
Bibi Hanım and teacher.
Let me find your here. Your presentation is here. Rational functions, yes?
Yes.
Great. Let's start, please, Bibi Hanım.
Hello, dears. I will perform with my partner Çiçek. Our topic is rational function asymptotes. We talk about introduction to rational function. First is a domain, second one vertical asymptote, third is horizontal asymptote, and fourth one slant asymptote. First of all,
interesting.
Introduction to rational function. A rational function is a function which is the ratio of polynomial functions. This form is Rx equal to Px multiplication Qx, where P and Q are polynomial functions. According to this definition, all polynomial functions are also rational functions.
Great.
Take Qx is equal 1. Check. Check.
Domain, vertical asymptote and horizontal asymptote. The domain of rational function of x includes all real numbers except the x values that make the denominator 0. If f is a rational function given by fx is equal nx over dx, vertical asymptote and zeros of dx. Domain. We have domain issue anytime the denominator of a fraction is 0. In the example below, we review this concept as well as some of the arithmetic of rational expressions. Example, find the domain of the following rational function. Write them in the form qx over px for polynomial function p and q and simplify. Fx is equal to x minus 1 over x plus 1. Solution. To find the domain of f, we find the zeros of the denominator and exclude them from the domain. Setting x plus 1 is equals 0 results in x is equal negative 1. Domain negative 1 and positive infinity. The expression fx is already in the form decreased, and when we check for common factors among the numerator and denominator, we find none. So we are done.
Okay.
Next page, horizontal asymptotes. Horizontal asymptotes are horizontal lines that the graph of the function approaches as x tends to positive identity or negative infinity. As the name indicates, they are parallel to the axis. Also, horizontal asymptote is the axis and y is 0.
Continue.
To find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. If n is less than m, then horizontal asymptote is the axis. Y is 0. If n is equal n, then the horizontal asymptote is y equal a over b. If n is greater than m, then there is no horizontal asymptote. Next page.
Location of horizontal asymptotes.
Location of horizontal asymptote. Theorem. Location of horizontal asymptote. Suppose R
is a
rational function and x, px over qx, where pq upon b respectively. If the degree of px is the same as the degree of qx, then y over p is the horizontal asymptote of the graph of y is equal rx.
Y is equal to rx, yes?
Yes.
And you gave an example and solution for this asymptotes, for horizontal asymptotes, and really great. The degree of the numerator is 2, and you find out that the degree of the denominator is 4, as is clearly seen from the example. And since n is less than m, then the line y is equal to 0 is a horizontal asymptote. Yes, great. And vertical asymptote. What about the vertical asymptote? Give a brief information about vertical asymptote, and then we will continue with item. Okay, vertical asymptote, please continue.
Vertical asymptote, if x equal to p x over qx. To find the vertical asymptote, set the denominator qx to 0 and so forth. x. Vertical asymptote definition: the line x equal to c is called a vertical asymptote of the graph of a function y equal to x if as x and the vertical asymptotes and horizontal asymptote location and host. Location of vertical asymptotes and host. Suppose R is a rational function which can be written as Rx. Rx is equal to Px Px over Qx, where P and Q have no common zeros. Let C be a real numbers, which is not the domain of R. And example, if x equal to 2x over 2 power x power 2 minus 3. Solution: we first find all of the real numbers which aren't in the domain of if. So we solve x power 2 minus 3 and equal to 0 and get x equal to minus and plus and minus
square root of
3. This signs the expression
left-hand side and the square root of 3 to the right-hand side. Okay, continue, please.
And slant asymptotes definition: the line y equal to mx plus b, where m is not equal 0, is called a slant asymptote of the graph of the function y equal to if as x positive infinity or x is negative infinity. If x is mx plus b, and also the determination of slant asymptotes. Example: x equal to x power 2 minus 4x plus 2 over 1 plus x. Solution: the degree of numerator is 2 and the degree of denominator is 1 as a slant asymptote. To find it, we divide 1 minus x and minus x plus 1 into 2 power x minus 4x plus 2 and get a quotient of minus x plus 3. So our slant asymptote is y minus x plus 3.
Great. Thank you, Bibi Hanım. And here is the graph of rational functions. Steps for graphing rational functions. You mentioned the first step, find the domain. Second, reduce Rx. 3, find the x and y intercept, and etc. Thank you, girls. You have done a great work. Thank you for your hard work. Thank you for your diligentness. Great. And finally, Aydan, where is your presentation? Is here. Nermin Mansimova and Aydan Abdulsalamlı. Please start. Complex numbers. Yes.
Aydan, let's start.
I think Aydan's internet is problem.
Oh.
Nermin, please start you.
Okay. Hi everyone. My name is Nermin and my partner name is Aydan. Our subject name is complex number.
Yes, please. Aydan is here. Okay, Aydan.
Okay.
Aydan.
Complex numbers. Please, Aydan, start. Or let Nermin to continue. Okay, Nermin, continue. Aydan will start when she's ready.
Nermin, I'm here. I'm here.
Okay.
Okay.
Aydan. Continue.
Start imaginary number. Imaginary number. Are you ready?
Okay, start, Aydan. Continue, please. Imaginary numbers.
Imaginary number is one and as a real number multiplied by the imaginary unit e, which is defined by its property e squared 2 equal square power of 2 equal to minus 1. And the next.
Next, the definition.
Yes, here we can say that e equal to square root of minus 1. If a greater than 0, then square root of minus a equal to e times square root of a.
Okay.
The next.
Complex numbers definition.
Yeah.
Please.
Nermin, are you here?
Yes. Complex number definition. A complex number is any number that can be written in the form a plus b times I, where a and b are real numbers. Note that a and b both can be can be 0. For example, 7 plus 2 times I squared root equal 3 over 1, etc. Next page.
You mentioned that 7 plus 2 times I. Here, the real parts are 7 and 2. The imaginary part is
real part is
7. The imaginary part is 2.
Imaginary part. Yes.
Yes, great. Let's continue. The complex numbers. Here is the table, yes?
Yes.
Yes.
The complex number.
Here we can see example about I spoke. They are just example.
Okay, and the complex number consists of a real part and imaginary part.
Yes, A is real part and B is imaginary part. Yes. And the next
basic operation.
As a third, the operation number are the same sorts. Here we are going to speak addition, subtraction, multiplication, and division. And let's start speak about addition. We are going to speak about addition. To add number, first add real parts and then imaginary parts.
they cannot be combined any further. Just retail add the real parts and then that's all. That's all. Nermin, the next.
Yes, subtraction. To subtract to complex number, first distribute the negative to the second complex number, and third treat as adding complex numbers. Example 1, I read.
Read, please.
4 minus 3 times I minus negative 8 plus 2 times I equal at last 12 minus 5 times I.
Firstly, we subtract the real parts, then we subtract the imaginary parts. Yes?
Yes.
Great. And the multiplication.
Yes.
And the division. Who wants to talk about multiplication? Nermin. Nermin or Aydan? Please.
Okay, next application. To multiply complex number, multiply the real number and imaginary parts. And we here can see example. I need to read. I need I read example?
You don't need. But in order to multiply, then first we should multiply the real parts,
yes,
then imaginary.
Yes,
we should multiply this as rational numbers. So division. What about
division? Division. Goal is to write the quotient of a complex number I, the format a plus 1. Multiply the numerator and denominator by the complex conjugate of the denominator. The denominator simplifies to a complex number. Third, the denominator simplifies to a single real number. Fourth, divide the denominator into each part of the numerator and write the result in a plus b times I format.
Great. Yes. And
the next
complex conjugate.
Page about complex conjugate. Yes, what's conjugate complex number? If two complex numbers differ only in the sign of the imaginary part, then they are called conjugate complex number. Thus, x plus e times y and minus e times y are conjugate complex number. And that's all. Thank you for all of the attention.
Thanks.
Thank you, girls.
Yes.
You did a great job. Keep going. Thank you for your such a perfect presentation. Really, you gave very important information, and I'll use your presentations in my next lessons. Okay, thank you. You are my diligent, industrious students.
Thanks.
I love you. Let's continue.
We
also we love you.
Yes.
You.
Thank you, teacher.
Thanks.
Okay, let's continue with Sama and Fidan. Okay?
Okay.
Let me admit. Okay, Sama, your presentation is about age word problems. Please.
Yes. Açarsınız mı?
Let me screen share, sorry. Start, please.
Okay. Hello. I am Sama Bashirova, and my partner name is Fidan Alibali. We want to speak about age word problems. Next
page. 1 minute.
What we will learn today about age word problems. First, what is age word problems and why do we solve age word problems? Second, important statements and equation for problems based on age. Third, exercise and solution of the age word problems.
Let me change the page. And first is what's the age word problems?
Yes. Let's start the lesson by learning definition. Age word problems are algebra word problems that deal with the age of problems people currently, in the past or in the future. Age type word problems generally compare two persons' age, possibly at different times in their lives. Why do we solve age problems? An application of linear equation is what are called age problems. When we are solving age problems, we generally will be comparing the age of the two people, both now and in the future or past. Using the class given in the problems, we will be working to find their current age. There can be a lot of information in these problems, and we can easily get lost in all information. To help analyze and solve our problem, we will fill out tables for each problem.
Important statement and equation for problem based on age. If the present age is y, then n times the present age equal ny. If the present age is x, then age n years later or hence equal x plus n. If the present age is x, then age n years ago equal x minus n. The age is a ratio AB will be AX and BX. If the current age
Can you stop the video?
Yes.
You don't want to open. Okay. Continue.
If the current age is a way, then 1 over n of the age is y over n. Examples and solution of the age word problems. If the problems involves a single person, then it is similar to integer problem. Read the problem carefully to determine the relationship between the numbers. This is shown in the examples involving a single person. If the age problems involve the age of 2 or more people, then using a table would be a good idea. A table will help you to organize the information and to write the equations. This is shown in the examples involving more than one person. Examples are more important in these topics.
How to solve problems involving a single person?
You don't need to explain the examples because I see that they are really clearly explained in the presentation. But let's continue with example 3. Who wants?
Gabby is 1 year more than twice Larry's age. 3 years from now, Megan will be 27, less than twice Gabby's age. 4 years ago, Megan was 1 year less than 3 times Larry's age. How old will Megan be 3 years from now? We know first time, present, future, past. Present
present Larry is L, Megan is M, Gabby is G. Equation G equal twice L plus 1. Future Larry L plus 3, Megan M plus 3, Gabby G plus 3. Equation Megan plus 3 and 2, Gabby plus 3 minus 2 past L minus 4, M minus 4, G minus 4, M equation M minus 4 equals 3, L minus 4 minus 1. After M plus 3 equal 2, G plus 3 minus 7, the end, we solved these problems. The end, Larry present times years old 13, Megan 30, Gabby 27, future Larry 16, Gaban 33, Gabby 30, past Larry 19 years old, Megan 26, Gabby 23.
And your last slide. Dear Mass, please grow up and solve your own problems. I'm tired of solving them for you. Great. Thank you, girls. Hope one day Mass will grow and solve his or her own problems. Okay, great. Thank you, girls. Thank you for your patience. Thank you for your effort. And this is, I guess, the end of all the presentations. Yes?
Yes.
Yes.
Okay,
Yes, teacher.
great. And
Thanks, teacher.
thank you all. I think at the end of the terms, we will not be light-handed, okay? We learned something despite the online platform. At the end of this term, we will not be light-handed, and this is why I love you. I love you, really. Thank you. Thank you for everything.
Yes, we love you.
Okay, this is the end of our
lovely teacher.
Yes. Thank you.
Really.
You too.
Your teacher.
Okay, this is the end of our presentations. All of you got the greatest degree. Thank you for all, and see you in our next lesson.
See you.
Bye.
See you.
Thanks. Bye, teacher.
Bye.